businesses to make business success stories possible and to make Go sort of a player in this ecosystem. And so enter GoKit, right? GoKit is a set of higher-order abstractions from microservices, fundamentally. Like Go, it has strong idioms and opinions, but it's not too opinionated in the sense that we don't need you to reinvent your architecture to use it. Okay. So if you've played in the space before, you might be familiar with projects like Finagle from Twitter. GoKit's very similar to that in design. Netflix has a project called Ribbon, which is part of a constellation of services. It's also very similar to that as well. So let's define our boundaries by setting some goals. What should GoKit do? First of all, GoKit should make Go a first-class citizen at the application layer. So in your typical architecture, you have at the top the internet-facing stuff that we're running HA proxy or Nginx. At the bottom, you have your data layer, databases, data services. But in the middle, where you pay, what you pay your programmers to do is your application layer, your business logic. And that's where I think GoKit should be targeted. Another goal is that we want to target the microservice or service-oriented architecture. We're focused on things important to that kind of architecture. And that's because our target market has overwhelmingly chosen to adopt that architecture. We're going to treat RPC as the primary messaging pattern. That's just a start. We're not fundamentally opposed to other patterns. We just want to use it as sort of a rallying point to cover 80% of the cases so that we can get to a usable state very quickly. We want to operate in a mixed environment in the sense that we don't expect to have complete buy-in into your organization. We want to make it easy to step into GoKit and take pieces on a piecemeal basis. GoKit services must play nice with existing services. We don't expect you to blow away all of your existing code and work. We also want to support pluggable transports in the sense that your business logic should be decoupled from the way you access it. One service should theoretically be available over many transports, perhaps even in the same process. And again, this is keeping in the same idea of we don't want you to blow away your infrastructure. We want to be able to say, if you're using Drift, GoKit services can work with Drift. If you're using HTTP JSON, they can work there too. We also want to strongly encourage best practices. Our contributors so far, and hopefully in the future, have experience in large-scale infrastructures. We've made these mistakes, but you don't have to repeat in your organization. And this can be a big selling point, especially to organizations that are a bit smaller, or perhaps on the fence about using Go. It's a good selling point to engineering directors and managers and that sort of thing. Okay, so just as important as goals, in my opinion, are non-goals. We sort of put a border at the things we're not interested in doing. Let's talk about a few non-goals. One non-goal is that we're not going to require any specific infrastructure or have any infrastructure dependencies. That means we're not going to rely on a particular log store. We're not going to need you to be running etcd somewhere. We're going to work in any scale environment and grow with your organization. So GoKit services are going to work if you're copying SCP binaries to DigitalOcean droplets, or if you're scheduling services on a 10,000 empty subcluster. Equally good. Another non-goal is that we're not going to have opinions about orchestration. GoKit services can be deployed, run, and supervised however your organization sees fit to do it. So that means if you're deploying devs and RPMs directly, fine. If you're using Chef or Puppet or Ansible or Salt, fine. If you're using a container engine, Docker, Rocket, doesn't matter. If you're using a container OS, Core OS, Rancher OS, Atomic. If you're running your own platform as a service, it's all fine. We don't care. Another non-goal is that we don't have opinions about configuration. We don't mandate a specific mechanism of build or runtime configuration, whether it's environment variables, flags, configuration files, all okay. And the theme to these non-goals, I think, is that we want to eliminate barriers to adoption. We want to make it as easy as possible to say, GoKit is something you can try, see how it works. And I think if we're able to get people hooked, then they're going to get hooked on Go. Okay, so that's the boundaries of the project. Now let's talk about the pieces. And I'll run through these kind of quickly. Don't get too caught up on the details. I just want to give you an overview. Before I start, we need to talk about what is a service, actually. What is a service? Is it a blue box? No. It's a thing, right? It's a thing that exists. Things talk to it, it talks to other things. And it turns out if you're building a distributed system like this, you need certain stuff that you might even not be aware of. So some of those things are like, for example, rate limiting on ingress and egress. You might need circuit breaking when you're talking to downstream services, so if they start failing, you don't break your infrastructure. You do things like service discovery and load balancing to find out where those things live and then control your access to them. And then even within the service, you need things like logging and metrics to make sure you know what's going on. And then for the system as a whole, you need, it turns out, you need a system of request tracing, like Google's Dapper or Twitter's Civkin. So you can see what's happening when a request gets to the top of your infrastructure, goes all the way down to all of your stuff, and then comes back out. These things are important. So this is sort of the domain of what we're working in. And then if you open up the cover of this blue square, you see within the service, there's actually sort of an onion, layers of things you need to consider. At the core is your business logic, of course, what they're paying you to do, but that's not nearly enough. You need to wrap that with stuff like metrics and instrumentation so you can see what's going on and you're not guessing. Wrapping it in that, you need things like analytics, so you can know what's my daily active user rate. You need to be able to compute that accurately. And that information needs to come from a very low level. Then at a higher level, we talk about the service level. We talk about connectivity between services. Simply establishing the connections is one area of concern. And then making sure you use them safely. When they fail, you need to reconnect, so forth. And then you need metrics of all of that stuff so that your operations team can know what's going on. This is all very important. And then at the top level, you need transports to make things even speakable, communicable with other things in your infrastructure. So I want to draw this kind of like dividing line. Some things you care about very deeply, that's your domain. Other things that kind of generalize a bit, that's GoKid's domain. And that's what we're going to give to you if you choose to go with us. Okay, so we're talking about RPCs, right? And sort of the core concept of the RPC is what I call an endpoint. So we start with that. That's sort of the atom of GoKid, this idea of an endpoint. It's a fundamental building block of clients and servers. It represents a single RPC method and it's generalized. So it's a function that takes a request and returns a response. Because we need to pass information across these layers of the onion, we use this context package, which is quite good. If you haven't seen it, I encourage you to take a look at it. I won't get into it in too much detail in this talk. But that's threaded through every endpoint. If you have endpoints, you can define middlewares. Middleware is something that, concretely, is a function that takes an endpoint and returns an endpoint, but it allows you to compose behavior modifiers, chainable, value and add kind of behavior modifiers that let you implement all the things we saw in that diagram. I learned recently this is also called a decorator pattern. Maybe that's more familiar to you. So you're going to define a service and you're going to implement it as a collection of endpoints. Once you have an endpoint, you need to make it exposable to the world. So most bindings can be made directly from your service to the relevant transport library. We define a binding as something which wraps an endpoint and then implements whatever your transport mechanism needs. Now let's go down into the service a little bit. Package log is one of the packages that GoKid is going to provide you. We've had a hard-won lesson here from a lot of experience. Package log takes the strong opinion that structured logging is mandatory. So that means that if you're used to logging just a string printf thing, GoKid says that's not a good idea. But it turns out if you pay that cost, you get a benefit. Not only are your logs much more easily machine parsable, the log package is equally useful both for application logging and log structured data pipelines like Storm or Kafka. We're still iterating on the best API here. Big thanks to Chris Hines, who I think is here. Thanks very much. Yeah, he's been helping us a lot. Similarly, package metrics go within the service. This is sort of the boiled down distilled version of stuff we've learned at SoundCloud and elsewhere. We provide 3 interfaces that you can use to instrument your code. And then each of the interfaces supports a variety of backends of implementations that go to whatever metric service or instrumentation service you happen to have in your infrastructure. Big thanks to Prometheus team and to Coda Hale for helping us nail this in. Okay, so now we get into some of the value add stuff, which is interesting. Rate limits is, as it should be obvious, it's a rate limiter you can stick on the server or client. It's implemented as a middleware, so you pass it the parameters and then it returns a middleware that wraps something else. So big thanks to Roger Pepe, did I say that right? And Tomas Sanax, who contributed quite a great deal to this. We also have something called a circuit breaker. If you're not familiar, it's something that sits on a client and says, if you start noticing that all of your requests are failing, open the circuit, break the circuit, and say, we're not going to send any more requests downstream until it starts better. It turns out if you have a large infrastructure, these things are critical. So we provide several implementations of circuit breakers, and you can wire them into your service. Similarly, load balancer, it's sort of a collection of things, and it's where we do our service discovery. So we have this concept of a publisher, which emits a constantly up-to-date stream of endpoints of the same thing, instances of the same service. You wrap that with a load balancer, which has different strategies around robin, random, weighted, health checked, this sort of thing. And then you wrap that in something which returns endpoints you can use without knowing all the details. Right now we have implementations for DNS SRD, console and CD support is planned, others as we need them. Tracing is the implementation of the request tracing system. So right now we have Zipkin, we're planning to support Halfdash, and if anybody else uses anything else, we're happy to support there. The idea is you annotate all of your incoming and outgoing requests with information about timing and this sort of thing, and then you can build sort of a tree of call graph, so to speak. Okay, so these are like some of the components. Let's wire them together into an example service so we kind of see how this all works. And to motivate an example service, let's consider something called an add service. A one-method service that has a single method add takes two integers and returns an integer. It turns out that can be simplified to just a function type, an add func, that is a function that takes two integers and returns an integer. We'll do that for the example. And a simple implementation would be a pure add, which just returns A plus B. Straightforward enough. Okay, because we're doing this using generalized RPC semantics, we need to define request and response types. So a request type is just all the parameters, and a response is just the return value. Easy enough. The signature of our add function is in our business domain. We care about integers in our business domain. But we need to somehow lift it to the endpoint domain so that we can start caring about network stuff. So let's write an adapter to lift our add function into an endpoint. And that's what this does. It would be a little bit more straightforward, except for this context thing. It turns out when you use a context, you're part of a call graph that can be canceled at any point of your ancestors can cancel you. So you need to be sort of cognizant of that. And you need to, that's what this highlighted line does. It says if we're ever canceled, then abort our processing. Otherwise, carry on. And all this does is just invoke the add function using the request and response interfaces. Okay, straightforward. So we had our business domain, we lifted it into the endpoint domain. And now we need to lift the endpoint into our transport domain. To do that, we use something that we call a binding. A binding is something that wraps an endpoint and makes it callable over some transport. Let's take gRPC just because the semantics are nice. A gRPC binding wraps an endpoint. It implements this add function. The add function does the same thing as the other lifter did. It just translates from one domain to another, basically. Bear in mind that gRPC requires a protocol definition of our service. Here it is. Not a big deal. Okay, so now, if we have our add func, we can wrap it with an endpoint. And we can wrap our endpoint with a binding. And then we can expose the binding according to the rules of our transport, and that's kind of what this is, step by step. And of course, this will be slightly different for every transport. I'm very sorry for doing that error. I know I should never do that. I know the presentation. I forgive you. So, this is fine, but it seems like quite a lot of ceremony, right? Like, I could have done this a lot easier without all these layers of abstraction. Why did I bother, right? It turns out that we're driving to a goal. And the goal is to enable us to build all this value-add stuff that we need in a way that composes nicely and looks nice and is extendable and all these lovely things. So, let's think about one such concern. We've implemented our app, but we don't know anything about it. We want to log all the requests to it, presumably. So we could do that by implementing a endpoint middleware, which is a function that takes an endpoint and returns an endpoint. But then we have to do like type assertions or something to get our parameters and return values out, and that's not great. So alternatively, we can define sort of a business middleware, and that's the same pattern. It takes a add func and returns an add func, but now we have access to the parameters of the add func, and so we can do things with them. So if we have this, then we can implement logging as a composable middleware, or as a composable decorator. And if you're interested in the idea of decorators, I'm also be doing a talk that goes into some detail about it tomorrow, I believe. So a decorator is something that takes some parameters and it returns a middleware. Middleware is something that takes a function and returns a function. So that is an implementation of the add function. So we have this sort of three stack. But then once you're in there, you have access to all these interesting bits, right? So we can defer a function that's going to log all the parameters and how long the request took, and then invoke the thing that we're wrapping and then return. And this is a really powerful pattern, as it turns out. It enables this thing that I call declarative composition. It allows us to compose business middlewares around the add function by using these well-understood chaining techniques. Here I kind of spell it out, but there's helper methods that do this a little bit nicer too. We can compose endpoint middlewares in the same way. These are things that deal with endpoint domain concerns, can be composed together. And what happens is when you do this, you get a func main that's really easy to read and reason about. And this is what it looks like. Minus a few things, this is really the complete func main for our ad service. We define our add function. We say it's going to be a pure add function. It's our business logic. We wrap it with logging and instrumentation. Cool. Then we define an endpoint, which is the lifted add function. We wrap it with our GoKit domain endpoint middlewares. And then you expose it using the gRPC language. It's pretty cool. And that's what we're driving to. If you remember back to the box diagram where I had the onion layers, we have exactly the same thing here, right? Above the line is your domain, below the line is the GoKit domain. Really quickly, a slide about clients. An endpoint is just something, a function effectively that takes a request and returns a response. You can serve that in the server. You can also call that as a client. So an endpoint can be used in both servers and clients, and that's nice because it means that we get all this value-added middleware equally applicable to both servers and clients. We can use the same set of tools. So on the client side, you would maybe make an endpoint that is a function of a gRPC dial, and then you wrap it with a circuit breaker, rate limiter, whatever else you need to. Same set of tools. Nice. So is this a good idea? What I just showed you? I don't know. Maybe not. But it seems like a good place to start. And it's important, I think, that we have a story here. Even if this isn't the final form of it, I think we need to start talking about this and start showing some code. I don't know. Good place to start. Okay. So what's next in the GoKit world? Well, we have a pretty concrete to-do list. We have some near-term things, a lot of things that we know we need to implement or want to implement. There are issues filed for all this stuff. Longer term, I want to build tools to adapt, to generate these adapters and these bindings. It's a lot of boilerplate. I think it can be done. I'm not sure how yet. We want to expand our example coverage. That's, of course, very important. And as I mentioned earlier, we want to support messaging patterns beyond just simple RPC. But beyond the to-do list, I'm really interested, and I think what's most important is to get your use cases. GoKit is community-driven, like everything in the Go community, and it benefits from everyone's experience. If you've done this at your organization before, this type of thing, I want to hear from you to learn from your experience. And perhaps even more importantly, if you want to do something like this in your organization, if you want to bring Go into your company in the application domain for your business logic, and you need some help, you need GoKit to do something it doesn't currently do, it's not currently on the roadmap, I want to hear from you too. That's really important to me. And with these things, I hope that we can take Go to the next level. It's already becoming the language of the server. I think it can become the language of the modern enterprise. And I think that's what we need if we're going to see Go reach its next level of adoption in the community. And that's really all I have. Thanks very much for listening.
Specifically asking about how this middleware for the case of as the underlying transport. So you talk about proposing adding the regulated patterning and business logic, which works great in HTTP because the handler is just a response writer, the signature is well defined. But for a case like this, each method has its own signature. You can't write a generic decorator. Is the idea to use the middleware draft our endpoint in that case, and how much do we do? Like, do we have a good solution there?
Okay, so I'm sorry, there's quite a bit of echo. I think I got most of your question. The point was that, for example, grid decorators are tied to the specific method. But what we want to do is potentially not tied to the specific method. We want to decorate our business domain, right? Yeah, and so that's why, indeed, why I draw the distinction between the endpoint domain and the business domain. If you want to decorate stuff that you care about as an organization, you should decorate your business domain. If you want to decorate stuff that your ops guys care about, for lack of a better word, you should decorate the transport domain. Yeah, so that's why that exists. And we can delve into that maybe offline. Yeah. Cool. Go over here.
Hey. All right, so you mentioned a bunch of services, such as service discovery, that kind of thing. Are you looking to integrate with some queues? Because I feel like that's a fundamental thing.
Yeah, so the question was, we're integrating with service discovery infrastructure, and the question is, do we want to integrate with queues? So I guess you mean like Rabbit queues kind of thing?
Yeah, Rabbit, Kafka, that kind of.
Yeah, so it's all like application specific, right? Like, what do you want to do with that queue? And the answer is yes, of course. A lot of people are using like Rabbit, for example, to pass all of their communication over and use it as like a message bus pattern. We want to get there. For other things, like it just depends on the application. I know someone asked for like an interface to a log server. They want to do like log server things, and that's definitely something that would be in the GoKit domain. Yeah, but we just don't have a concrete use case for it yet that I've seen. Cool. Thanks.
For organizations that are already using, say, the Netflix stack or the Twitter stack, are there any plans for interop with those stacks so that we can introduce those to those works?
Yeah, that's a great question. So the question was, organizations already using an existing stack, what are the plans for interop? And that's sort of the whole idea, right? Interop means a couple of things on a couple of different levels. At a minimum, it means playing nicely. And so that's definitely what we want to do. We want to play nicely. We want to interop with, for example, part of the Twitter stack is a Zipkin server, right? So we export to Zipkin as one of our core things that we do. Part of the Netflix stack is this Hystrix sort of like connection monitor idea. To the degree that that's possible, we want to integrate with that. I want to make it clear that GoKit doesn't intend to replace these things. It merely intends to raise Go to a level that is on the same playing field. And so we want to have very strong interop, very strong compatibility promises. Yeah, exactly. You can't quite close anybody there.
Hi. It sounds like the GoKit will be very flexible. You can choose your transport, you can choose your service discovery tool, etc. But also when you're coming to it, you just want to learn from the tutorial, and it's a new project or you're just playing with it. Like, would you be recommending instead of, documenting and saying, if you don't have the opinion to use this?
Yeah, that's a great question. And it's like the developer bootstrap, the first cut question. And yeah, it's really interesting. I think GoKit should have opinions on this because there's so many possibilities. We can definitely have a few bootstrap guys given a certain set of opinions. For example, Halo has some it's a ride-sharing company in the UK. They have some very strong opinions. And if you want to follow the Halo model, then maybe we could show you the GoKit way to build a Halo-like stack. If you want to follow the Netflix model, we could have some guides do that sort of thing. But I totally agree with you that this is super important, especially for developers starting out. And then if you don't nail that story, everything else kind of doesn't matter. So yeah, I'm totally agree with you on that. Yeah. I guess last question, unfortunately. Sure.
So, I feel like these generic frameworks tend to come with a traditional set of problems, right? One of them is all of these transports, for example, are special one way or another. You put them into a generic framework and now you've shaved off all the things that made them special. Another problem is now my code is unoptimized and confusing because it has to go through all this generic stuff in the middle that's going to be super flexible.
Yeah.
So I'm wondering, I'm sure you're aware of those kind of issues. I'm wondering how you think you'll be able to navigate around them.
Yeah. So there's two things here. I guess one is a set of performance concerns, and one is a set of conceptual concerns. So on the performance side, I guess, the opinion of GoKit, at least right now, is that your latency is going to be dominated by your business logic. And so all this like machination that we do, translating between domains, in the end, it's not super optimized right now, but in the end, it's not going to matter. So that's why we have request and responses like the MD interface. I can't say a word that begins with G on stage under pain of death, but let's just say that that's not ideal, and I'm looking into ways to make that not true. Conceptually, there's a problem of, indeed, like Thrift gives you stuff that you don't necessarily want to throw away. And in order to enable the goals that I would say I want to enable, we kind of have to throw that away. The way to solve that over time is to bring the Thrift stuff deeper into the stack, and the way to do that is an open question. So I don't have an answer for you right now, but know that I'm aware, and yeah, it's something we're going to be doing in the future. Okay, my clock says 0. Thank you very much. I will be in the hack day. We're going to have a GoKit hack space. It's not official, but it will be somewhere, so come find me if you have more questions or if you want to do hacking. It's a very accessible code base, so that's a good thing. Thanks again.